Hey fam, welcome to Driven Math and Physics. So today we're going to be looking at some problems on Archimedes principle. And so in this problem, we've been given the mass of a metal sphere, okay, which is 300. So we know that the mass of the sphere is equal to 300 grams, and the density of the sphere is equal to 7,500 kgs per cubic meters, okay. And this thing is fully immersed. That's the key word, fully immersed. That means it's going to displace water equal to its own volume. So what will happen is once it's fully immersed, the water that will be displaced will be of the same volume as the object. Okay, that's why this is the key word. Okay, and then from there we know that the density of the oil is equal to 850 kgs per cubic meter. Okay, so they're using a light string for this. So they're saying draw a diagram showing all the forces acting on the sphere. Okay, so if we drew a diagram of this, it means it will be hanging like that. Then the sphere will be something like this. This thing is immersed in oil. Okay, and the first thing that we know is that the first force, whenever there's a string, and that force that will be acting is what? Tension. Okay, but there will also be an upthrust from the fluid. But at the same time, the object will have what? Weight. Okay, so those are the three forces. We have two upward forces. We have the upthrust and the tension, and then we have the downward force of weight. So if this thing is held in equilibrium, okay, that means the upward forces should equal the downward force. Very important here for you to know. So the diagram itself is what determines that equation. Okay, so the second question here is saying calculate the tension in the string. So we need to find T in this equation. How do we do it? First of all, we need to know the upthrust. We need to know the weight of the object in air. Okay, what is the weight of these objects? We know its mass, we know its density. We can find weight. Okay, so now weight is equal to mass times acceleration due to gravity or gravitational field strength. So from there, the mass will be 300 grams divided by 1,000 grams. Okay, sorry about this. Let me just write it properly. Okay, so it will be 300 divided by 1,000. That will give us kgs times 10 newtons per kg. Okay, these two cancel out and those cancel. We end up having 3 newtons. That's our weight. Okay, so we have found the weight. What next? We need to find the upthrust. Remember, upthrust is equal to weight of the liquid displaced, and this is from Archimedes' principle itself. So that means upthrust will be equal to rho, which is density of the liquid displaced, times, okay, the liquid in this case is oil, times the volume of the liquid displaced, which will be equal to the volume of the object because it is fully immersed, times gravitational field strength. Okay, so the density of the fluid, which is oil here, is 850 kgs per cubic meters multiplied by, okay, so multiplied by the volume of the liquid displaced. Okay, do we know the volume of the object? No, we don't, but we can find it. How do we find it? Easy. Remember that density is equal to mass over volume. Therefore, volume is equal to mass over density. And so the mass of this thing is 300 grams is the same as 0.3 kgs. So that's 0.3 kgs divided by the density of this object is 7,500 kgs per cubic meter. This will give us the volume of the object, which will be equal to the volume of the liquid displaced because it was fully immersed. Okay, so from there we multiply again by gravitational field strength, which is 10 newtons per kg. Okay, so once you work it out, you'll find that the upthrust is equal to 0.34 newtons. Okay, you can check that as well with your calculators and see if you find the same thing. Okay, so now let's make tension subject to the formula in this equation right here. So it will be equal to tension is equal to weight of the object in air minus upthrust. The weight of the object in air is 3 newtons. Upthrust is equal to 0.34 newtons. This gives us 2.66 newtons. And once you have done that, you have found the tension in the string. Okay. I hope you're able to find the same thing. But yeah, let's finish this up. Okay, the final question is saying, what happens to the tension if the oil is replaced with water? So for you to understand that, you have to realize here that this equation tells you exactly how tension relates to weight and the upthrust. What will happen is, if you change the fluid, okay, if you change the fluid, what will change is not the weight of the object. The weight of the object will be intact, it will be the same, it will be 3 newtons. But what will change is the upthrust it experiences, because now the liquid has changed and the density has changed. So if you look at the liquid itself, the density of the oil is 850, but the density of water is equal to 1000, okay, kgs per cubic meter. So that means if we change from oil to water, the density has what? Increased. And once density increases, the upthrust that the object will experience will also be higher. If the upthrust is higher, what will happen to the tension? It will decrease. Okay, so that's what happens there. So you can relate it to that and then come up with your own conclusions. Otherwise, thank you so much for tuning in. This is all for today.